All right, guys, here we go. We get to learn a new shape today. That is the trapezoid. So maybe you remember a little bit about trapezoids, and if not, we are going to cover it all. So we're going to be talking about a lot of vocabulary today. So I've kind of organized it here in the notes. So please feel free to print those out to kind of keep everything in one spot. All right, so a trapezoid. This is what we usually think of when we think of a trapezoid, although they don't always have to look like that. It could look like this as well. This is actually called a right trapezoid because there's a right angle right there. But a trapezoid is a quadrilateral with, do you see those two marks? Exactly one pair of parallel sides. Now that's the thing that actually makes it different from a parallelogram, because if you remember, a parallelogram, not only are the top and the bottom parallel, but the left and the right would be parallel also. Well, in a trapezoid, it's only one set of parallel sides, not two. So sometimes it'll be the top and the bottom, sometimes it might be the left and the right. So it could look something like this as well. So it doesn't have to be the top and the bottom, but it's going to have exactly one pair of parallel sides. Now, do you happen to remember the vocab word that describes those parallel sides? They're called the bases. So in this case, AB and DC are both bases because they're the parallel sides. Now, the ones that are not parallel, these two guys here, those are called the legs. All right, now, we also have something called base angles. Now, base angles would be like angle D and angle C, but also angle A. Now, I marked those, let me back up. I marked those so they look like they're congruent. They're not necessarily congruent. I'm just marking them so you can see which angle I'm talking about. So angle D and angle C, not necessarily congruent, but they are base angles. Angle A, let's see if I have another color. Angle A and angle B, also base angles. So there are going to be two pairs of base angles. And those base angles are going to be the angles that touch the same base. So you can see that angle A and angle B touch AB, so they're a pair of base angles. Angle D and angle C touch DC, so they're a pair of base angles. All right, so let's take a second here and look at example 1. So using all of these definitions and vocabulary up here, we're going to see what we can do to label this picture with these things. So I would like for you to pause the video and try to fill these out, or just think about what your answer would be in your head and then unpause and see what you came up with. All right, so our bases for this, we can see we've got those two parallel marks there. So it's going to be AC, segment AC. So I put the segment symbol on top, and segment EH. Again, another segment, so segment symbol on top. The legs are the non-parallel sides, so that's going to be those two. So that'll be AE and CH. One pair of base angles is angle A and angle C, because they're both touching this one parallel side. So angle A and angle C. That means the other pair of base angles is going to be the angles touching the other base, which is base EH. So that'll be angle E and angle H. Now, something we haven't talked about yet are the diagonals. Now, we do have diagonals in parallelograms, and you might remember that those are the lines or the segments that connect opposite angles. So I can do the same thing in this parallelogram. So EC is a diagonal, and AH, connect those opposite angles. All right, now, number 6. Did you come up with anything? So angle A is supplementary with what other angle? So don't forget that supplementary means it's going to add to 180 degrees with this other angle. So I'm going to erase these just for a second so we can just look at the whole angle. So angle A is this guy right here. It needs to add to 180 degrees with another angle. Well, if we just use some logical thinking, angle A is an obtuse angle because it's bigger than 90, and angle C is an obtuse angle because it's bigger than 90. So A and C would add to be more than 180, so it's not going to be those two. Now, angle A and angle E, this one's obtuse and that one's acute, so they definitely could add to 180 degrees. So the question is, can we prove that they do? Well, if these two sides are parallel, those are our parallel lines, right? And if you remember from chapter, gosh, I don't know, 2, maybe? If you have two parallel lines cut by a transversal, these two angles right here are called same side interior, or maybe your teacher said consecutive interior. So angle A and angle E are consecutive interior angles, and because they're formed by parallel lines, that means they're supplementary. So angle A would be supplementary with angle E. Now, angle A and angle H might be supplementary, but we don't have any like opposite angle theorems or like parallel line theorems with opposite angles. So this is a maybe, but we don't have enough information to prove it. Where with angle E, we know these are consecutive interior angles, so they're supplementary. Okay, so you might remember from this guy the other day, right? We've got our quadrilaterals. They split into parallelograms and then a whole bunch of parallelograms. And then separate from that is trapezoid. Do you see off of a trapezoid, there's another kind of trapezoid called an isosceles trapezoid. So we're actually going to fill this out next time, but for right now I just wanted to use the visual. So a trapezoid, can you guess what the definition is going to be? It's a quadrilateral with exactly one pair of parallel sides. So that means since an isosceles trapezoid is off of a trapezoid, it will have exactly one pair of parallel sides, but it has a couple other special things as well. So an isosceles trapezoid is a trapezoid whose legs are congruent. So what does that mean? Well, in this trapezoid, you can see, oh, I forgot to fill these in. This is a leg and this is a leg. You can see that these two legs, they do not look congruent. So this would not be an isosceles trapezoid. So an isosceles trapezoid is going to have congruent legs. So if you look at this one, these actually kind of look like they might be a little bit more congruent. This might represent an isosceles trapezoid. So you cannot assume they're congruent, but if somebody told you it was an isosceles trapezoid, then you would know the legs are congruent. So let me draw you an isosceles trapezoid. We know it's a trapezoid because the bases are parallel. If this is an isosceles trapezoid, that leg and that leg would be congruent to each other. So if that's true, then each pair of base angles, which would be this angle here and this angle here, these two angles right here, these base angles, they will be congruent. So each pair of base angles are congruent. Now don't forget there's two pairs of base angles. We have these two down here. We also have these two up here. So both sets will be congruent. Now they're not going to be congruent to each other, but they will be congruent base angles. Now one other thing, another property that you might probably not guess, but the diagonals of a trapezoid, of an isosceles trapezoid, only the isosceles, the diagonals of the isosceles trapezoid are congruent, which means when you draw them in, this whole thing will be congruent to that whole thing. Do you remember what other shape had the congruent diagonals? It was a type of parallelogram. The rectangle and the square also have congruent diagonals, but a rectangle and a square are not trapezoids. They just happen to have the same property because a rectangle and a square have two pairs of parallel sides and a trapezoid only has one. All right, so let's look at example 2. Now we've got some more information. I'd like for you to pause the video again and see if you can fill in the blanks. Okay, so we know this is an isosceles trapezoid, which means we've got parallel sides and congruent legs. So name the congruent sides and mark them in the figure. Oh, I just did that. So our congruent sides are EN and RI. And then don't forget those segment symbols. Draw in the diagonals. So EI, diagonals are connecting the opposite angles, and NR. So EI would be congruent to NR. Now don't forget with segments, you can put these letters in any order you want. So I could say EN or NE, it doesn't matter. So if I write it backward from you, that is okay as long as we have the same two letters. All right, so angle ENI, so ENI, that's this entire angle. Now that's actually a base angle, so it's going to be congruent to its other base angle, which would be over here, angle NIR. You could call it RIN, angle NIR. As long as I is in the middle, it doesn't matter where the N and the R go. All right, so angle NER, that's this angle here. That's also a base angle. It's a base angle with angle R. So it should be congruent, because it's a base angle, with ERI. Okay, so now we're got the hang of identifying things. So we're going to actually be identifying and doing a little bit of problem solving now. So let's look at example 3. So we have a trapezoid. I know it's a trapezoid because it told me, but I also know because they're a little tiny, but I do have 2 parallel marks there. Only one set, so I know this is a trapezoid. All right, is this an isosceles trapezoid? Well, we don't have enough information to tell us. It didn't say up here it was isosceles. The legs are not marked congruent. And actually, AT and KN, those look like 2 different sizes. So not isosceles. So we have to make sure we're careful, because only the isosceles triangle has congruent base angles and congruent diagonals and legs that are congruent. The regular trapezoid doesn't have any of those things, okay? So we just have to make sure we're thinking about that going forward. All right, so we want to find the measure of angle ATK. ATK, so that's this angle right here. All right, so is ATK 143 degrees? Because these 2 angles are base angles. Well, maybe, but this isn't isosceles, which means we don't know the base angles are congruent, so this is probably not 143. So if this is not 143, then how do we find it? Well, if you remember up here in example 6, or number 6 from example 1, we knew that angle A was supplementary with angle E because of the consecutive interior angles. So A and E, we could add those together to equal 180. So what would add together with angle T to equal 180? Well, it would be this guy right here. So we can do 180 minus 61. That should equal angle T right here. So that would be 129 degrees. All right, so let's look at KNA. KNA. So we want to know this angle right here. Now, is angle N equal to 61? Maybe, but we don't have enough information because we don't know this is isosceles again, so we can't say that those are congruent. Also, they don't quite look congruent either. All right, so how do we find angle N? Well, we're going to do it in the same way. So these 2 angles, angle K and angle N, those again are consecutive interior angles, so they will be supplementary. So we're going to do 180 minus 143 to get that number. So that would be 37 degrees. Awesome. All right, moving on. All right, so for these ones, what do we know? Use isosceles trapezoid LAZY to solve the problem. All right, this right here is supposed to be over here. So in number 1, if LA is 5x minus 3, LA, 5x minus 3, and ZY is 4x plus 6, 4x plus 6, find ZY. So in order for us to find ZY, the length of ZY, we need to find x, so we can plug x in and then just figure out how long it is. All right, so how do we do that? Well, if this is isosceles, remember we have a couple things that are true about isosceles. The legs are congruent, the base angles are congruent, and the diagonals are congruent. What is LA and ZY? Are those base angles, legs, or diagonals? Those are legs, which means they're congruent. So the legs are congruent. because it's isosceles. So that means LA is going to equal ZY. So 5x minus 3 is going to equal 4x plus 6. And now we're just going to go ahead and solve it for x. So feel free to work ahead of me. So I'm going to subtract 4x. I'm going to add 3. So x equals 9. Now it's really important to make sure you know what you're looking for. So I'm not looking for just x, I'm asked to find zy. So I can't stop here. I need to make sure I plug it back into zy. So if zy is equal to 4x, and I know x is 9, plus 6, this will be 36 plus 6. So zy is equal to 42 units. All right, number 2. ZL is 2n plus 3. So this whole thing, I got to draw it in, it's not in here, is 2n plus 3. And AY, got to draw that one in too, is 5n minus 9. So that's where this comes in. We're going to find the value of n. So this time we're just looking for the variable. We're not looking for the length of the diagonals, which both ZL and AY are diagonals. Now this is still an isosceles trapezoid, which means the diagonals are congruent. So that means LZ or ZL is equal to AY. So just plug in what you know. 2n plus 3 is equal to 5n minus 9. And now we go ahead and solve it. You can solve it in whatever way you want. How I solve it isn't the right way, it's just one way. So let's see, negative 3n equals, I got negative 3n equals negative 12. Divide by negative 3. Did you do the same way or a different way? Did you get the same answer? Because that's the goal, to get the same answer, right? So I got n equals 4. Now we can actually make sure this is right because the diagonals are supposed to be congruent if we plug it in. So if I do 2 times 4 plus 3, that should be the same as 5 times 4 minus 9. So that'll be 8 plus 3, which is 11, and 20 minus 9, which is 11. So I know for sure that that's right. All right, moving on, number 3. Again, please feel free to work ahead and then just use the video to check yourself. So if the measure of LAZ, that's this angle right here, is 6W, and ALY, that's this one right here, is 12W. Find the value of W. Okay, this is an isosceles trapezoid, which means the base angles are congruent. Are L and A base angles? They actually are not, because they're not touching the same base, they're touching the same leg. So L and Y would be congruent, and angle A and angle Z would be congruent, but L and A are not congruent, so we don't want to set them equal. What do we do then? Well, these are consecutive interior angles, and that means they're going to be supplementary. So if we add them together, they will equal 180 degrees. W equals, I got 10. What'd you get? All right, so how can we find out if this is right? We were able to plug the 4 in to get the same length for our diagonals. How would we know if this is right? Well, we plug in 10, so this would be 120, so 12 times 10. And this would be 60, 6 times 10. And these two together should equal 180, and 120 plus 60 is equal to 180, so we know we got it right. All right, number 4. If the measure of angle L is 3x plus 12, and the measure of angle Z is x, find the value of x. So this one's a little bit tricky at first glance. We do not have any kind of property or definition of a trapezoid that says anything about opposite angles. But this is isosceles, which means the base angles are congruent. So angle A is congruent to angle X. Well, if this angle Z is congruent to that angle A, and this is represented by X, couldn't we also say that's X because they're congruent? And then once we know that, aren't these two angles just like these two angles over here? They're consecutive interior, which means they are supplementary. Did you remember that vocab word? So angle L and angle A are going to be supplementary. So 3x plus 12 plus x equals 180. 4x plus 12 equals 180. 168, divide both sides by 4, x equals 42 degrees, because x is actually representing an angle, so our units would be degrees. Awesome. All right, so we've put into practice some of the things that we know about trapezoids and isosceles trapezoids. We're going to learn one more vocabulary word, and that is median. So you may recognize this word from when you were in algebra. You use it like mean, median, and mode. Do you remember that? And the median was the number that was exactly in the middle. So like if we had 3, 8, and 6, and we would cross off each end and then find the one that was, oops, these need to go in order, I suppose. We would cross off the ends until we found the one that was in the middle. Do you remember what we would do if we had an even number? So if we had like 1, 2, 3, and 4, and I said find the median? Well, when we cross them off and there's two numbers in the middle, do you remember? Add them together, divide by 2. All right, so that is very closely related to what we're going to do here. So the median is the segment that joins the midpoints of the legs of a trapezoid. All right, so what does that mean, first of all? Well, if I have a trapezoid, it can be isosceles or not isosceles. I'm going to draw mine so it doesn't look isosceles. If I were to find the midpoint of this leg and the midpoint of this leg and connect them together, this right here is the median. So this is a midpoint and this is a midpoint. So that's cut in half and that's cut in half. This here is the median. Now the median is always going to be parallel to the bases, first of all. Parallel to the bases. And the length of the median is exactly halfway between the length of the bases. So this goes back to that idea of like when you find the median, what do you do if you have two things in the middle? How do you find the middle if you have two things? So like the median is the middle of these two bases, which means we can add the length of each of these together and divide by 2. So let's say this were 2 and this were 4. And we wanted to find the median. Well, first of all, using logical thinking, what is literally halfway between 2 and 4? Well, it would be 3. If we use this idea though, 2 plus 4 is 6. Half of 6 would be 3. If this were 12 and this were 14, well, halfway between 12 and 14 would be 13. But if we add these together, 12 plus 14 is 26, and half of 26 is 13. So we can use this right here to help us find the length and the median anytime we need it. So here's our last example. Segment FE is the median. We're going to find the length of FE, the median, if AD is 10 and BC is 30. All right, this you might be able to do in your head. Great, do it. But if you need to use this formula, what we're going to do is add the bases together. So 10 plus 30, and then we're going to cut in half, divided by 2. So 40 divided by 2 is 20. Now, does that make sense? Is 20 halfway between 10 and 30? You can always tell because the distance here will be the same as the distance here. So 10 plus 10 would be 20, and then 20 plus 10 would be 30. So the distance will always be the same. All right, now we're going to find the median of trapezoid ADEF. So we just found the trapezoid of ADCB, which was FE. But now we're going to find the median of ADEF. ADEF, that's this, which means we need to find the midpoint, connect them. So from the first one, we know this is 10. We just found the median to be 20. So now we need to find this new median right here. Well, you might be able to do that in your head, what's halfway between 10 and 20. But if not, it's okay. You don't have to do it in your head. 10 plus 20, cut it in half, divided by 2. 30 divided by 2. So our new median would be 15. All right, if you have any questions about the stuff from today, I know it was kind of a lot, please reach out. Otherwise, have a fantastic day.